We can write a quadratic equation from many different forms. We'll focus on from a table and from a graph today to be able to write the equation. Typically what we're going to be looking for are the x-intercepts. So if we take a look at this, I see that one of the x-intercepts is already located in the table at -2, 0. I do not know what the other one is. However, I do have enough information to be able to find that out. If you take a look at this in the bottom, I see this duplication of y values occurring, which means symmetry has already started. So those two values would be paired up. Likewise, I should then be able to pair up the next two values. So I believe this is going to be 1, 0. Now we have found the other x-intercept. At this point, we're going to rewrite those x-intercepts as x equals. So this would be x equals -2. This would be x equals 1. Now we want to write them as factors. We want equals 0. So we're basically going to put the x and the number on the same side together. So each of those two items that we just created, x plus 2 and x minus 1, those are going to be the factors that we use. So we start building our equation. I know I'm going to have an x plus 2 and an x minus 1. What I don't know is what the a value is for this. So I'm going to put an a in. It's going to be something that I have to calculate myself. So back to the table. In the table, you want to choose two other values. You just cannot choose the two that were already used, the -2, 0 and the 1, 0. So I am going to use the 0, 6. If I use the point 0, 6, then wherever my y is, I'm going to plug in a 6, and wherever my x's are, I'm going to plug in a 0. Bring everything else down. Now solve for a. The entire right-hand side, once you simplify what's inside the parentheses, does become multiplication. So to eliminate that multiplication of -2, we are going to divide by -2. It looks like our a is -3. Go back to the equation where we had the a with the factors and plug the -3 in its place. This is the factored form of the answer. If you needed to state the standard form, then you would need to multiply out all of the factors. And the resulting equation for the standard form would be -3x squared minus 3x plus 6. Either of these answers is correct. We also want to be able to identify an equation based off of the graph. We're still looking for the x-intercepts. So take a look. It looks like we have an x-intercept at x equals -4 and an additional x-intercept at x equals -1. We go through the same process. We want them to be equal to 0. So this is going to give us x plus 4 equals 0. And this one will give us x plus 1 equals 0. That x plus 4 and x plus 1 are our factors. So we're going to use those to start building our equation. Where I do not know what a is, so I'm going to put a placeholder in for that. Now, back to the graph. You need to locate one additional point. We want a lattice point. Lattice point is a point where the graph crosses the corner of the grid. So the point would be an integer, no decimals, no fractions. It looks like we have a choice here at 0, 2. So I'm going to use 0, 2 as the point. So everywhere you see a y, you plug in a 2. Everywhere you see an x, you plug in a 0. Everything else comes down. Simplify what's inside the parentheses. multiply the two parentheses, and then divide to solve for a. Looks like a is equal to a half. So one of the equations in factored form would be half times the two factors, x plus 4, x plus 1. That's one version of the answer. Again, that is the factored form. If you're required to give the standard form, then we would multiply all of these terms together. That would give us half x squared, 5 halves x, plus 2. That is also the correct answer.